The improvement team decided to study whether the transit damage rate was the same for all distributions. They collected data on the units sold, that is transported, and transit damage claims for each distributor for the past year. The distributors are labeled 1, 2, 3, 4, 5, 6, 7, 8 up to 27. There are two clear outliers on the scatter plot. Let's do the scatter plot. So click in an empty cell, click on Insert, click on Chart, and chart type, select scatter plot. Take this to on sheet. Let's edit the chart. For the data range, let's select units transported, and add another range, that is units damaged. Click on OK. Now let's label the vertical, the axis. Chart title, let's put units damaged. Damaged versus units transported. And for the horizontal axis, let's put the title as units transported. Let's select minimum and maximum values. So for the horizontal axis, let's put 0. And maximum value, let's put 2,500. For the vertical axis, for the minimum value, let's put 0. And for the maximum value, let's put 90. And vertical axis title, let's put units damaged. Okay, so we have the chart over here, and we can see that in the spreadsheet, this value here for the units damaged 68 and the units transported 503, and this value here, this data point for the units damaged 22 and the units transported 1502, these are the two outliers. So there are two clear outliers on the scatter plot. Explain briefly what effect that would have on regression line. So the effect on the regression line will be, the regression line will be diverted towards towards the outliers. The regression line would be attracted toward both outliers because it tries to minimize the sum of squared errors. This would cause it to rotate clockwise slightly. The correlation coefficient would be reduced because they increase the unexplained variation. So let's fit a regression line to this chart. Let's click on edit chart, then customize, click on series and add a trend line. Let's look at the R squared. Show R squared value takes 0.63. So this shows that the data is R squared equals 0.63. So R, the correlation coefficient will be square root of 0.63, and which will be so equal to square root of correl. Let's find the correlation coefficient equal correl of the dependent values. That's for the units damaged, comma, space, then select the independent values. And close the bracket. The correlation coefficient is 0.79396, which shows that the fitted line is not very accurate. I briefly explain how the two outliers could provide valuable clues to help in reduction of transit damage. We would want to find out why the outlier corresponding to x equal 50 units transported equal 503 and units transported equal 1502 had such high levels of units damaged and such low levels of units damaged. Example, is there some lack of equipment or poor training, etc. And why the outlier corresponding to x equal 1502 and y equal 22 was so good. How do these two distributors differ from all the rest? So for units transported 503, the units damaged is 68. So we would want to find out if there was some lack of equipment or poor training. But the units transported equal 1502, units damaged was 22, was so good. When the two outliers are removed from the data set, the following scatter plot is obtained. So let's obtain that scatter plot. So let's copy this table. And we'll put the table over here. So let's delete this table. So, so for the units transported equal 503 and units damaged equal 68 was one outlier. So we'll remove that and we'll move the cells up. And for the units transported 1502, the units damaged was 22, and that was also the outlier. So let's remove that. Okay, so now distributor, so the distributor equal this was 14, so this equals this plus 2. Okay, so distributor 13 is removed and distributor 27 is removed. So let's obtain the spreadsheet, the scatter plot. So insert. So this chart, let's rename it scatter plot. And let's go to the distributor data. And now we plot the scatter plot with the outliers, 2 outliers removed. So click on insert, click on chart. The chart type, select scatter plot. And let's take this to the on sheet. Let's edit the chart. Let's select the units transported. And let's add another range. Let's select the units damaged. Let's let's customize the chart. For the chart and axis title, for the vertical axis title, let's put units damaged. And for the horizontal axis title, let's put units transported. And for the chart title, let's put units damaged versus units transported by distributor. Let's look at the minimum and maximum values. For the horizontal axis, put the minimum value has 0 and the maximum value has 2500. And for the vertical axis, Let's put the minimum value as 0 and the maximum value as 90. Let's put a trend line. So click on series and click on tick the trend line. And we want to show the R squared value. So the R squared value is 0.932, which is much higher than what we had before with the outliers, which was 0.63. And let's show the equation of the trend line. So customize series. We want to show the equation. So use equation. Select use equation under label. Index 0.0373 times x plus 0.77. So this is, let's label this, rename it as fresh outliers removed. Okay, so now when the two outliers are removed from the data set, the following scatter plot is obtained. What is the value of the correlation coefficient? So the correlation coefficient, so we'll type equal correl of the dependent variable comma, then select the independent variable, independent values, that is for units transported. Close the bracket. So we get 0.9654, 57636. So interpret this value. So R equals 0.965 approximately to 3 decimal place, which is a very high positive correlation, indicating that a regression line should be a good fit to the data. The correlation should be causal because if the units transported are increased, then there is a more chance of damage occurring. So as we can see, there is the units transported increase, there is more units damaged. So the value of R squared is 0.932 to 3 decimal place. Explain the meaning of this value in the context of this situation. So it means that 93.21% of the variation in the units damaged is explained by its dependence on units transported. Explain why the constant the constant, which is from here, and this is the regression line equation. So let's find it again. Equal lineage of, let's choose the dependent values, comma, let's choose the independent values. Close the bracket. So explain why the constant 0.699503 in the regression equation is expected to be close to 0. This is the y-intercept, the value of y when x equals 0. When 0 units are transported, we would expect the transit damage to be 0. How should the constant 0.03733380 in the regression equation be interpreted? So 0.0373 equal gradient of the line. Units damage increase by 0.0373 per extra unit transported, or 3.73 damaged units per extra 100 units transported. Calculate the estimated number of units damaged for a distributor receiving 5,000 units during the past year. What concerns should you have with this estimate? So that comes to 187.460179 units damaged. What concerns should you have with this estimate? Now looking at the data range for units transported, we look at 0 to 2,500, but 5,000 units are way out of the range. It's the extrapolation, and that implies unreliable prediction. The following data is part of the output from the regression tool using the data with the outliers removed. In the table, the predicted value and residual for distributor 1, that is observation 1, is missing. Calculate the predicted units damaged and the residual for distributor 1. So this equals to the constant plus the coefficient multiplied by I32. So I32 is 1,726. And for the residuals, that equals to the units damaged, which is 70, minus the predicted value, the predicted units damaged. Okay, so okay, so now what happens is that we from here, so when we look at 12, so that's all right. And when we look at this, it's all right. Okay, now we will, so now that we have predicted for the distributor 1, we will study the residual plot. So we will, to study the residual plot, we need to plot the residual plot. So click on Insert, click on Chart, and for the chart type, select Spreadsheet, Scatter Chart. And for the data range, okay, before the data range, let's move this to the on sheet and click on Edit Chart, click on data range, add another range, and let's select the distributor, the units transported, values, and then let's select the other range, and let's select residuals. Let's click on OK and customize. So chart and axis title, let's put for the chart title, let's put residual plot. And for the horizontal axis title, let's put units transported. And for the vertical axis title, let's put residuals. And for the horizontal axis, let's put the minimum value has 0 and the maximum value has 2500. And let's choose the vertical axis is all right. Okay, so now what does the residual plot show? The residual plot shows that the residuals are distributed around the 0 line. What should be conducted about the validity of fitting a line to this set of data? Give a reason. What should be concluded about the validity of fitting a line to this set of data? The residual plot shows that the line is a good fit to the data as the residuals form a horizontal band indicating that the distribution of errors is the same for all values of x. What does the residual plot indicate about the distribution of errors about the regression line? The errors about the regression line seem to be distributed with mean close to 0 and have an approximate spread of plus or minus 10 units. So as we can see, the residuals are having plus or minus 10 units and the average is 0. So the errors about the regression line seem to be distributed with mean close to 0 and have an approximate spread of plus or minus 10 units.